What's up, guys? In this video, I went through my back catalog and found 20 different examples of me simplifying radicals. I start with just simplifying the square root of a number. Then we expand that with variables. Then we move on to the cube root, the fourth root, as well as the fifth root. I hand selected these problems to help you understand how to simplify radical expressions. So if you go from the beginning to the end, at the end, you will have a strong foundation of how to simplify radical expressions. I hope you enjoy.
All right, so here we have the square root of a number that's not a square number. Okay, so what we've previously talked about is when we have the square root of a square number, the squares cancel out and we're left with an x. So that was very helpful when we had like the square root of 25, because we know we could rewrite that as 5 squared, which equaled, or the square root of 5 squared, which equaled 5. Right? Yep. Well, here we got a problem because 24 is not a square number, right? We can't rewrite this as a number squared equals 24 where we could just cancel them out. So what I'm going to do is I'm going to look to the square numbers that I do know and see if some way we can rewrite 24 with those square numbers. So the square numbers I do know is 4, 9, 16, 25. And obviously I'm not going to keep on going because it's above 24. Yep. So we know 4, that's equal to 2 squared. This is equal to 3 squared. That's equal to 4 squared. And that's equal to 5 squared, right? Yep. So I could take the square root of any of these numbers and I would get 2, 3, 4, 5, right? You understand how the canceling out would work? Yep. So what I want to do is I want to see, can I rewrite 24 as a multiplication, of one of these square numbers in there. So can I rewrite 24 as maybe like a product of one of these numbers and another number, as a multiple of one of these numbers? So think about it. Could I rewrite, obviously 25 does not evenly go into 24, yeah. So that's not going to work. Could I rewrite 16 as a multiple to equal 24?
No.
No, not as a whole number, right?
No.
Does 9 evenly go into 24?
No.
No. Does 4 evenly go into 24?
Yes.
Yeah, it does. All right. So 4 evenly goes in there 6 times. So what I'm going to do is I can rewrite this as 4 times 6. Right? I haven't changed the math problem at all. I haven't changed anything. I just rewrite 24 as 4 times 6.
Yep.
Now, the only reason why I want to do that, like I said, we're trying to simplify this. So now I can say, oh, well, I can rewrite 4 as 2 squared. 2 squared times 6. And that helps me out because now, going back to this rule, when you have the square root of something squared, they cancel out and equal x. So the square root of 2 squared is going to cancel out. However, I cannot rewrite 6 as that squared number, can I?
No.
So that 6 is going to have to remain under the radical. It only cancels out for the 2. So therefore, my final answer, the 2 gets pulled out from the radical, but I'm left with 2 radical 6.
On the square root of 32, is 32 a square number? No. So what we have to do now is apply our rules of radicals. I'm going to want to separate 32. I'm going to want to separate 32 into a product of 2 numbers. And can I break up 32 into a square number? Is there a square number that divides into 32? 16 and 4, right? You always want to choose the highest square number to make sure it's simplified. 16 is the largest square number, so what I'm going to do is I'm going to break this up into 16 times 2. Now, just for this, I usually don't go to this next step, but just for this process, I'm going to do that. Based on my rules of radicals, if I have 16 times 2, does it make sense to break that up into square root of 16 times the square root of 2? Yes. Yeah, that's using that rule of radical, right? So for this example only, I'm just going to do it this way. I usually don't do this next step. I just usually skip this step just because it's, it's extra work. So now, can I rewrite the square root of 16 as a number squared? 4 squared, right? However, can I rewrite 2 as a number squared? So guess what? I can't use the identity element on this. So guess what? It stays. So my final answer is 4 square root of 2.
Okay, what I'd like to do is show you 3 different ways to
to simplify this radical square root of 50. So there's a couple things we need to, first of all, get out of the way before we do this. The first thing, you can only take the square root of square numbers, right? So let's go over a couple square numbers. The square root of 1 is equal to 1. The square root of 4 is equal to 2. The square root of 9 is equal to 3. The square root of 16 is equal to 4. Let's say we got the square root of 25 is equal to 5. The square root of 36 equal to 6. The square root of 49 is equal to 7. And the square root of 64 is equal to 8. Okay? So I wanted to write those down for you guys to understand that you can't, square root of 50 is not a square number, is it? All right? So what we're going to do is we're going to manipulate the square root of 50 into using numbers that I can take the square root of. So what I'm going to do is I'm going to do this 3 different ways. Okay, the first way is I'm going to say, well, what square numbers go into 50? And you could say, well, let's look at all these numbers. 1 obviously goes into 150, but I'm not going to simplify, right? 4 does not go into 50. 9 does not go into 50. These evenly. 16 does not go into 50 evenly. 25 does. How many times does 25 go into 50? It goes in there 2 times. So what I'm going to do is, instead of writing the square root of 50, I'm going to rewrite the square root of 25 times 2. Now, here's not my third way, but here's the biggest misconception. Students always say, oh, 5 times 10, that's easy. All right? Or what we could also do is do square root of 5 times 10. All right? And what we're going to do is actually factor this one, and I'll show you how this one works. Okay, so what happens here is, let's see this. Now, it's square root of 25 times 2. How can I break this apart? Well, if I show you guys something, if I say square root of 36 equals the square root of 9 times 4, you'd probably agree that, yes, 9 times 4 is equal to 36. Well, I can rewrite this as the square root of 9 times the square root of 4, because square root of 9 is 3 times the square root of 4 is 2. 3 times 2 is equal to 6, as the square root of 36 is equal to 6. So therefore, if I have two numbers under a radical and they're multiplied by each other, I can break them up. So I'm going to break this up into square root of 25 times the square root of 2. The square root of 25 is 5 times square root of 2. Done. Here, can you take the square root of 5? No. Can you take the square root of 10? No. So this is not how you simplify a radical. You have to choose numbers that you can take the square root of. 5 and 10 are not any two numbers you can take the square root of. However, if you want to use it by factoring, you can choose 5 and 10. So here's how you use it by factoring. If I have 5 and 10, right, what you're going to do is you want to factor these. All right, now 5, I cannot factor any further besides 5 and 1. However, 10, I can factor as 5 times 2. Then what we say is we group these together. 5 times 5 is 5 squared, right? So it's kind of like 5 squared is just going to be 5. So what I can do is I'm rewriting this as 5 times 5, right, which I grouped, times 2. Well, 5 times 5 is 5 squared. The square root of 5 squared is just going to be 5. So I can take this out, what we like to say, pull it outside of the radical, and we say 5 times 2, which is my exact same answer. So there's 2 different ways to kind of solve this. One by finding it this way, and the other one by factoring. Whichever way kind of works for you is fine. I always prefer this method, but like I said, it just kind of depends on what you work with. So, but just be careful. If you're going to use this way, you have to choose numbers that you can take the radical of.
So let's do an example of taking the square root of 128. All right. Now, so I'm going to go over some. I'll do your fractions. I forgot about it. But let's go over taking the square root of 128. There's a couple ways that we mentioned to doing this. The first way was doing prime factorization. All right. If you can't figure out what square numbers go into this, then simply just go ahead and use prime factorization, which we can always just simplify this, right? Since this is an even, we know we can divide it by 2, correct? And then we can break this down into 8 times 8, 4 times 2, 4 times 2, 2 times 2, 2 times 2. So therefore, I can rewrite the square root of 128 as its prime factors of 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 7. 1, 2, 3, 4, 5, 6, 7. Thank you very much. All right, so now when we're taking the square root, when we do it prime factorization, remember we want to take out square root, we want to take out pairs of numbers. So we're just going to group 2 pairs of numbers. Therefore, I can take out 1, 2, 2 2s, 3 2s. And then this square root does not have a pair, so it's going to remain under. 2 times 2 times 2 is going to be 6 square root of 2. The other way, 2 times 4, thank you. 64, thank you. Yes, is that yours?
On the test, will we have to do every single one, or like the most we have to do is 3? 3, like.
Oh, you mean roots?
Yeah.
Yeah, you're going to only have to do a cube root, which I'll go over this problem next with the cube root. Now, let's just let's pretend though we had the other way to do this, which I think is much easier. If you notice, oh, well, 64 divides into that, right? So I would just rewrite that as 64 times 2. It's the same thing, right? You can do prime factorization. If you can't figure it out, do prime factorization and do this. It works. But I always like to rewrite it with the square number because I know that the square root of 64 is 8. Done. So on this one, it might be a little bit harder to kind of realize what exactly square number goes and divides into this. So what I would just tell you is if you check each one going from the largest to largest number possible in there. And we can look at some square roots. I'm pretty sure in this class we're not going to be doing anything that's going to be larger than 15 squared. So AJ, when you're looking at this, what I would do is I would just see which of these numbers, which is starting with the largest, is going to evenly divide into 343. And literally just take your calculator and you can say 343 divided by 225. 343 divided by 196. 343 divided by 169. When you have a large number like this, it might not be as apparent of what exactly is going to be your square number. But as you guys keep on going to that, what we see is we have a solution at 49, which I can rewrite this as square root of 49 times 7. All right. Does that make sense how you can rewrite the exact same number just as a product? I'm not changing the answer. It's the same thing, right? Yeah. Then what's nice about this is now I can take the square root of one of these numbers because this is a square number. That's 49, square root of 49, which I can take the square root of, which is 7 times the square root of 7. Now what I'd like you to do is check in your calculator. Just type in the square root of 343. Then type in your calculator the square root of 7 times 7. And guess what? They're the exact same thing. All right? However, this is what we call simplified. And this would be not simplified. However, their number value is exactly the same. Yes?
How do you know which number to put on the outside and which one to put on?
I'm not putting a number on the outside. I'm taking the square root of 49. The square root of 49 is 7. I can't take the square root of 7. It's not, square root of 7 is not up here. So I can't take the square root to get an even integer. So therefore, it stays under the radical. Does that make sense? Okay.
Okay. So we want to, you see it? Yep. We want to be able to take the square root of 64 and x to the 6. Now, it's pretty easy to remember the square root of 64, right? That's just your number. So what I'm going to do is, one thing you can remember, I'm just going to break this up. So I'm going to break this up into our number, square root of 64, times the square root of x to the 6. The square root of 64, we know the answer is going to be 8, right? Yes. But the one thing we need to understand is, what is going to be the square root of x to the 6? Well, there's a couple things to remember. The square root of x squared, right, we know equals x, yes, right? So we can take the square root of x squared, that's going to equal x. So what I want to do, and actually another thing for us to remember is the property of exponents, that x squared times to the third equals x to the 6. You're going to multiply those exponents, okay, right? Does it make sense? Yep. Okay, those are rules of exponents. So what I'm going to do is I'm going to see how I can rewrite x to the 6th with a square root. Okay. Okay. So what I'm going to do is if I can rewrite this, if we can rewrite this as x cubed squared, then what happens is, like I said, these square roots are going to cancel out. Right? So therefore I'm just left with 8x cubed.
All right.
Does that kind of make some sense?
Yeah, it makes
Do you want to
sense.
explain it a little bit in a different way?
If you like. All right.
Okay. Think about it this way. If we look at this, so here's x cubed. Let's look at it another way. So we have 64 x to the 6th. Another way, remember how we write, we know that this is represented as 8, times 8, and that's how we get our 8 out. Well, x to the 6th can be rewritten as, x cubed times x cubed.
All right.
So, pretty much when we're taking this out, this that equals, right? Because if you have x cubed plus 3 equals x to the 6th, right?
Okay.
So all I'm pretty much saying is, we know that this equals 8 squared, which is still 64, and this would equal x cubed squared. Well, again, whenever you're taking the square root of those cancel out, and those cancel out. So that's why we're just left with 8x cubed. Make
Right.
sense?
Yep.
Okay.
So the main important thing, when we're looking at variables, with numbers, we got to have numbers that we can take the square root of, right? For variables, we got to take variables that we can take the square root of. So when I look at, I'm taking the square root, so I know that m squared, I can take the square root of that, right? Square root of m squared is m, and I know I can take the square root of p squared, which is just going to equal p. So one way what we can do is, let's rewrite this as far as many squared numbers as possible. So therefore, I can rewrite this as m squared times m squared times m squared times m squared. Yes? Because remember when you multiply variables with exponents, you add the exponents. So 2, 4, 6, 8. Then times p squared times p squared. So now I can take the square root of all of these numbers, correct?
Do you got it?
And this is the exact same thing as that.
Do you have to do that in the second step?
Well, yeah, there's other ways you can do it.
But
But let me show you, I'll show you a different one in a second. So now we do m, square root of m squared is m, square root of m squared times m times m times m times p times p. Because when I take the square root of all these, that's what I get. So m times m times m times m is m to the 4th times p squared.
So the
Now-
square root's like dividing it by 2.
You're not really dividing it by 2, you're undoing it. The square root of m squared, remember what square root says what two numbers multiplied by themselves equal m. Well, that would be m, because m times m is m squared, right? So let's continue it. What about if I said the square root of m to the 4th? Well, the square root of m to the 4th is the same thing as the square root of m squared times m squared, which is equal to m times m, which is equal to m squared. So the square root of m to the 4th power is m squared. So I could have done this a little bit easier. I could have said m to the 8th, or the square root of m to the 8th times p to the 4th is really m to the 4th times m to the 4th times p to the 4th. Well, what's the square root of m to the 4th? M squared. So we're going to have m squared times the square root of p to the 4th, which would just be p squared, which you guys see m squared times m squared is m to the 4th p squared, which would have been our exact same answer. Okay?
Welcome. So what I want to do today is show you how to simplify this radical expression here. So I have negative 2 times the square root of 490 times b to the 5th. So the way that I'm going to solve this problem is take a look at by factoring it. Okay, so we're going to look at the factors of a problem, and there's one thing I want to go through before we even talk about factors, is just think about the square root of a number. If I take the square root of 4, right, we know the answer is 2, but I can rewrite the square root of 4 as 2 times 2, right? So whenever we have two factors that are the same, we can take the square root of them.
and to equal, your 2, right? So what I'm going to do is I'm going to factor these under the square root, and anytime that I have a pair of factors, I know I can take that number or that factor out of the square root. So what we're going to do is I'm just going to kind of factor this out. So I need to factor 490, right? So I need to determine what number goes into 490. Well, thankfully, since it ends in a 0, I can see that 10 is going to go into it. So let's just rewrite this here. This is all under radical. So I can rewrite this as 49 times 10 times v to the 5th. Now v to the 5th is a special case because you want to say, how can you rewrite that? Well, that can be rewritten as v times v, right, 5 times. So I'll get to that in a second. So 49, if we factor that, that can be factored into 7 times 7, and 10 can be factored down into, let's just do 5 times 2, times v times v times v times v times v. Okay, this is what we call linearized factored form. What I've done is I have broken down this radicand to its linear factors, right? We can't factor any of these numbers any further. So now what I'm going to do is I'm going to take my pairs of numbers and pull them out because I know that the square root of 2 times 2, right? That's a pair equals 2. So I need to take what numbers can I pull out? Well, I have 7 times 7, a pair of v times v, and another pair of v times v. So I can take these numbers outside now of my radical. So I have negative 2 times 7 times v times what's left over, what's inside. 5 times 2, which is 10, times v. So now on the outside, I just need to simplify. Negative 2 times 7 is negative 14. V times v is v squared times the square root of 10v. And there we go, we got it simplified. Wasn't that bad, was it? So just make sure when you factor, we can pull out, since it's the square root, you're going to have to pull out pairs of numbers. And I'm not pulling out the whole pair, I'm just pulling out, remember the square root of 2 times 2 is 2. So there you go, hope you enjoyed. So we have the cube root of negative 8. So we need to remember what the cube root stands for. The cube root, right, stands for what number multiplied by itself 3 times is going to give you negative 8. Now it's really important, ladies and gentlemen, when dealing with an odd root, right, that if your root is negative, that means you're going to have a negative number. So we look at this, the cube root of negative 8 is going to be negative 2 times negative 2 times negative 2 equals negative 8. So therefore, we could say the cube root, what number multiplied by itself 3 times gives you negative 8, equals negative 2. Okay? We practiced taking the square root and cube roots of numbers, expressions. We did operations, blah, 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 blah. So basically, I just want to remind you guys of what the cube root represents. Cube root is what number multiplied by itself 3 times gives us 27. And hopefully, you guys can see that that can be written as 3 times 3 times 3. So the cube root of 3 times 3 times 3 is just 3. Thanks. Cube root says what number multiplied by itself 3 times gives you 27. Well, that's 3 times 3 times 3. Then the cube root says what number multiplied by itself 3 times gives you negative 27. Well, for an odd root, we can take the odd root of negative numbers. Because negative 3 times negative 3 times negative 3 gives us negative 27. Does everybody agree? OK. Now, for the square root means what number multiplied by itself twice gives us 27. Now, we can't do the square root of 27, but we can simplify that. And the way I'd simplify it would be 3. We know that it's 3 times 3 times 3. But square root only means a number multiplied by itself twice. So the square root of 3 times 3 would just be 3. And then I still have a 3 on the inside. So we can't take the square root of 27. But in this case, we can simplify it. However, we have an issue when we try to do the square root or any even root of a negative number. Because for this to be negative, what I want you guys to understand is I can't multiply this by, there's not 2 numbers that multiply to give you anything negative, right? I can only take out 2 numbers that are exactly the same.
So it has to be either positive 3 and positive 3, right? Positive 3 times, or no two numbers multiply to give you a negative 27. I can only take out the even root of 3. So it'd be 3 square root of negative 3. But what we're going to do is, we can't take the square root of a negative number. And let me just even go through, let's do negative 4, something that you can take the square root of. There's no two numbers that are exactly the same that multiply to give you negative 4. It's either 2 and 2 or negative 2 and negative 2, right? But both negative 2 and negative 2 and 2 and 2 give you positive 4, not negative 4. So this is impossible. So when taking the square root of a negative number, sure. So what we're going to do is we're going to rewrite this as 3 times the square root of 3 times negative 1. Does everybody see that? Is 3 times negative 1 the same thing as negative 3?
Sure.
Everybody agrees? Yes. So what we do is we rewrite the negative 1, the square root of negative 1, as our imaginary unit I. So it's 3 square root of 3 I. Now in this next one, if you guys take a look at this, it's a French word. So if you guys look at this problem over here, this one's looking for cubes. So I need to figure out what number multiplied by itself 3 times. Now, Richard, if you're having trouble with identifying the cube numbers, that's why I provided them over to you guys over there, because I know you guys aren't as familiar with cube numbers or numbers to the 4th power. So if you guys look at that, I wrote down the popular cube numbers. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, right? So you could see that I could rewrite this as 4 cubed. Right? Does that make sense? And then now I can apply the identity element and say that's just going to equal 4. Prime factorization always will work. Always rewrite the number as a product of its primes. For square root, you take out the pairs of numbers. For cube root, you take out the pairs of 3s. However, there is also that other way that we mentioned, was by rewriting a number in terms of its square, in terms of the squared number that divides into it. Do you guys remember doing that?
Yes.
All right, so we can do that same thing for cube roots. And I think actually doing it that method for cube roots is much easier, because there's only so many numbers available for the cube roots that you will probably be presented with. For instance, 2 cubed is equal to 8. 3 cubed is equal to 27. 4 cubed is equal to 64. 5 cubed is equal to 125. So can we rewrite 250 as a multiple of one of these numbers? Yeah, it's 125, right? So I could say the cube root of 125 times 2. Now, do we know what the cube root of 125 is? Yeah, it's 5, right? So therefore, I can just rewrite 5 times the cube root of 2. So for square root, sometimes it's difficult because there's so many square roots, right? You have 4, 9, 16, 25, 36. Sometimes it's a lot of numbers. But for here, if you guys can just look to see if you're taking a cube root, is it a multiple of one of these 4 numbers? Obviously, if it's a really large number, you'd probably want to go into looking at 6 cubed and 7 cubed and higher. But more than likely, more of the problems that you're going to look at will be divisible by one of these numbers. And then you can just simplify it the other way. So you don't even have to do prime factorization. So this one, we're trying to take the cube root of 8. Now, when you're having decimals, it kind of gets a little confusing. Obviously, having a calculator would be very helpful. If you didn't have a calculator, then it can be a little bit more difficult. But there is one thing we know. 8 is a cube number. Forget about the decimals for a second. We know that the cube root of 8 is equivalent to the cube root of 2 to the 3rd power, which is just 2. Correct? Does everybody follow me? Right? But we need to write this as something where it's going to give us this decimal. Now, first of all, this is negative, right? So if that was a negative 8, then that would be a negative 2, right? Because negative 2 times negative 2 is positive 4, times negative 2 would give us a negative 8. You can simplify the cube roots, or the odd roots, of negative radicands, right? Just not the even. You can't simplify the even root of negative radicand. All right, so there's a couple things for us to understand. First of all, 0.2 times 0.2 if you were to multiply 0.2 times 0.2, what happens is our decimal places move over to 0.04. And if you were to multiply 0.2 times 0.04, that would give you 0.008. So it works. Okay? So therefore, the decimal, if you guys can see, when you multiply 0.2 times 0.2, that gives you 0.04. Okay? And that's in your decimal operations. I'm not going to get into decimal operations. I'm just going to show you that's what it works out to be. So therefore, this answer would be cube root of negative 0.2 cubed. And if you have a calculator, you can try it. Guess and check. Do 0.2 times 0.2 times 0.2. Yes? Since you're taking the odd root, you can simplify negatives, positives. Okay? So your simplified answer would be a negative 0.2. So when you guys have decimals, your radicand is going to be a decimal, or your simplified version will be a decimal. So the main important thing, what I like to get you guys is, now the nice thing about variables is we can easily break them down. If you guys remember, numbers sometimes aren't as easily broken down. For instance, not everybody remembers that the cube root of 8 is 2 times 2 times 2, right? Not everybody remembers that. Not everybody remembers that the cube root of 64 is 4 times 4 times 4. All right, some of you guys got to get a little bit practice with, hopefully you guys remember the square numbers, but some of you guys might forget the square numbers, and cube numbers or numbers to the fourth root, Zach, even get more and more difficult. But with variables, variables are really nice because if you get stuck or you're having trouble with this, we always know that we could break this down into x times x times x times x times x times x times x. So I'm going to show you guys this a couple different ways. All right? And the first way I'm going to show you is the long way. All right? I'm going to show you the long way first, and then I'm going to show you a quicker way. So if I wanted to take the cube root of x to the 7th, remember the cube root says how many times you have to multiply a number by itself 3 times, right? So if I break up x to the 7th as x multiplied by itself 7 times, that's what x to the 7th represents, correct? Yes? Yes. No, the 3 is your index. So yes, you need to write that in there. So what the 3 represents is how many times you're going to multiply a number by itself. Well, what you guys notice is I'm multiplying the x by itself 3 times. And I'm multiplying the x by itself 3 times, right? So what is if you're taking the cube root of the x multiplied by itself 3 times, that is just going to equal x. Then this equals x times x. These are still separated by multiplication. And then I still have the cube root of 1 more x. But this x, it has to remain under the cube root. So it's the cube root of x. So your final answer, x times x is x squared, cube root of x. Remember, the cube root says what number multiplied by itself 3 times. Well, here, I'm multiplying x by itself 3 times. So that equals, those are the cube root. So think about it this way. The cube root, ladies and gentlemen, of x cubed is what? What's the cube root of x cubed? X. Is x times x times x equal to x cubed? Yeah. Yes. So the cube root of x times x times x is x. The cube root of x times x times x is x. The cube root of just x, I can't take the cube root of just x. So therefore, that's going to remain under the radicand. Or that's going to remain as the radicand. So therefore, I have x squared times the cube root of x. Now, the other way that you guys can look at this, another way that I like to do it, is exactly as I mentioned. If you guys understand that when you're taking the cube root, or when you're taking the index root of your radicand, you want these numbers to be the same. Do you guys agree? Because you can always take the cube root of a number raised to that power. So what you can do is rewrite this as x cubed times x cubed times x. Do you guys remember the rules of exponents that we did last class period, or that we did last chapter? What I did is I rewrote this. I rewrote. Right. What do we do when we multiply exponents? We add the powers. 3 plus 3 plus 1 is 7. And as I mentioned, going back to rule, can we take the cube root of x cubed? Cube root of x cubed is x. Cube root of x cubed is x. Cube root of x is just going to have to remain there. OK? again, ladies and gentlemen, the identity element states if you have nth power of a to the n, where a, remember, is the base. Now, we didn't talk about this. We only did problems where a was a number or a was a variable, correct? Yes? But a could also be an expression. It doesn't really matter what the base is. This could also be an expression. So do you guys see how this is really the cube root of a cubed, where a is equal to x minus 9? Do you guys kind of see that? So therefore, we can still do this. It's just an expression raised to a power rather than a number or a variable like we did in our examples. So therefore, by following the identity element, we just have x minus 9. OK? If you guys remember, the main important thing when simplifying is using our identity element. And if you guys remember, the identity element basically states when you have n, or the nth root of a to the nth power, that equals a. OK? That was like our main important thing when we talked about simplifying. Main important thing. So all we want to do is we basically want to be able to say, can we rewrite this as, instead of this expression, can we rewrite this as exponents, where a is your base and n is the same power as your index, which in this case is 3. All right? So I wrote these up there, and I am going to be erasing them pretty soon because they're taking up space. But I gave you guys a list of possible cubed, quartic, and square numbers that you guys should be recognized. So 216, as we go ahead and take a look at it, is, yes, that is going to be a cube number. That is the cube root of, 6 cubed. So I could say the cube root of 6 cubed. And if you guys plugged in your calculator, you'd see that 6 cubed is 216. Then I can rewrite x to the 4th. Remember the rules of exponents? X cubed times x to the 1st is equal to x to the 3 plus 1, which equals x to the 4th. Would everybody agree with that math right there? Yes. OK. So I can rewrite this as x cubed times x to the 1st power, if you want to, and then times y cubed. Does everybody see that? Now, let's go back through our identity element. Remember the identity element. Whenever I have an exponent raised to the same power as the index, it just equals my base. So Joseph, I have 6 cubed. I'm taking the cube root of that. So therefore, that just equals 6, right? The cube root of x cubed is just x. I can't take the cube root of x to the 1st. Those are not the same, so I'm going to leave that under the radical. And the cube root of y cubed is just going to be y. Therefore, the only thing left under is going to be the cube root of x to the 1st power, which I can just write as x. Anybody have any questions? No questions. What helps us out is the rules of exponents and the rules of radicals. That's what's going to help us out. So if you guys didn't write those down, make sure you guys have those, because even though those are kind of, at least the rules of exponents are a review, they're really helpful in this, because are these the same? No. The only way I can simplify it is if they are exactly the same. However, I can use the rules of exponents to help me out. I could rewrite this as the 4th root of x to the 4th times x squared. Would you guys agree with me that x to the 4th times x squared, based on the product rule, is x to the 6th? Yes. Now I can use my identity element. The 4th root of x to the 4th is x. I can't do anything with x to the 4th x squared, right? So that answer is x squared. Does that make sense? Más o menos? Just make sure, guys, you don't do something like x to the 5th and x to the 1st, because you can't do anything with that, right? You have to do your index where it's exactly the same. OK? Welcome, ladies and gentlemen. So what I'd like to do is show you how to simplify the fourth root of 81 times x to the 16th. Now, I'm going to do this in two separate ways. One thing that we noticed that if you have the square root of a times b, that equals the square root of a times the square root of b. And that doesn't matter if it doesn't matter if that's the fourth root or the square root. So what first thing I'm going to do is I'm going to break these up into dealing with the fourth root of 81 and then dealing with the fourth root of x to the 16th. Now, when dealing with numbers, unless you are able to identify what number multiplied by itself 4 times gives you 81, which square roots, sometimes people know the square roots because we use them so often, but fourth roots, it might not become so familiar with you. So a lot of times I say factorize it. Just break it down into its prime factorization. So 81 can be broken down into 9 times 9, and that can be factorized to 3 times 3 times 3 times 3. So that is what we call the prime factorization of 81, because 3 times 3 times 3 or 3 is not prime numbers, and they all multiply to give you 81. Now, when taking the square root of a number, for instance 4, we know that's 2, but square roots, you're looking for pairs of numbers to pull out. So when you're looking into the fourth root of 2 times 2 times 2 times 2, you're looking into 4 numbers that are the same. Just like with square root, you're looking for 2 numbers. Well, the 4 numbers that I'm multiplying by myself here is going to be 3. So the fourth root of 3 multiplied by itself 4 times is just going to be 3. Now, x to the 16th, you can do the same way. You can do the fourth root of x times itself 16 times and then do sets of 4. However, that's just a lot of writing. That's just a lot of writing x's in there, right? So the other way I like to look at it is looking at it this way. If I, instead of doing pairs, I could also say, well, the square root of 2 squared just gives us 2. So if I'm looking for the fourth root of 2 to the fourth, that equals 2. So I want to be able to rewrite I want to rewrite this in x to the 16th in terms of x to the fourth power. So how many x to the fourth powers do I need to multiply to give us x to the 16th? Now remember, when you multiply exponents with powers, you add the powers. Or exponents, you add the powers. So 4 plus 4 is 8, 12, 16th. And then I can take the fourth root of each of these individually. So then I'm just left with x times x times x times x, which is x to the fourth. And that will be my final simplified expression. Thanks. On this one, a lot of students get this one. A lot of students have trouble with this because, again, this is to the fifth power. Or, I'm sorry, to the fifth root. That's saying what number multiplied by itself 5 times is going to give us 32. So, ladies and gentlemen, the easiest thing, I showed you what the square numbers are. I showed you what cube numbers are, but I don't have a list of numbers to the third power. Or, I'm sorry, or the fifth power. So the best thing that I would recommend, ladies and gentlemen, is use a factor tree. 8 times 4. 2 times 2. 4 times 2. 2 times 2. And what you guys notice is 2 times 2 times 2 times 2 times 2 equals 32. So what number multiplied by itself 5 times gives you 32?
2.
2.
So clean.
Then, what is the fifth root? I can rewrite that as the fifth root of y to the fifth times y to the fifth, right? You guys agree with me? Because what's y to the fifth times y to the fifth? Y to the 10th, right? And what's the fifth root of y to the fifth? Y times the fifth root of y, so it's going to be 2y squared. Now I need to make this negative. Now I'm looking at this and I'm saying, all right, a negative number. Mr. McLogan, you always said negative numbers, right? That's going to be I, right? You can't take the square root of negative 1 because there's no 2 numbers that multiply to give you a negative 1, right? But remember, that's for the square root. That means square root means what number multiplied by itself. The cube root says what number multiplied by itself 5 times. Well, think about it. Negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. Times negative 2 is positive 16. And times negative 2 is going to give you negative 32. So now, instead of our answer being 2, we can write negative 2 to the fifth power. And then we said we rewrote this as y squared to the fifth. Well, now we undo our powers with our roots, and we have negative 2 y squared. All right, so guess what? I still comes into play, ladies and gentlemen, when we're dealing with even roots. I is going to come into play when you deal with a square, cubic, eighth root, whatever. Anytime it's even, you cannot take the square root of an even number. However, when it's odd, your answer is just simply going to be negative. All right? Cool. In this example, ladies and gentlemen, what we're looking for is the fifth root of 64y to the 10th. All right? Now, again, you might be saying, well, what number multiplied by itself 5 times is going to give me 64? Probably the easiest thing to do for this is just, again, to create a factor tree. 8 times 8, 4 times 2, 2 times 4, 2 times 2, 2 times 2. So therefore, I'm going to want to write down the prime factorization of 64, which is going to be 2 times 2 times 2 times 2 times 2 times 2. So 1, 2, 3, 4, 5, 6. And then y to the 10th, again, I can write y multiplied by itself 10 times, but I prefer to take it as y squared. How many times are you going to have to multiply y squared by itself to give you y to the 10th? 5 times. It's much quicker. So now what we do is, since I wrote the prime factorization of this, since we're taking the fifth root, how many of the y's do I need to take the fifth root of them? 5. So I go ahead and group 5. Then, so the fifth root of 5 2's multiplied by each other is just 2. Then I can, oops, I'm sorry, what am I doing? Come on, guys. I need to take y to the 5th power, right? So I need to do y to the 5th times y to the 5th, right? Not y squareds. I can't take the 5th root of y squared. I can only take the 5th root of y to the 5th. Deja, you should be paying attention to this.
Wait. I'm following you all the way up to the y to the 5th.
What's y to the 5th times y to the 5th?
Oh, gotcha.
So what I did is I wrote it as y to the 5th, though, because I can take the 5th root of y to the 5th, right? If this was a different number, I couldn't take the 5th root of it. So the 5th root of y to the 5th is y. The 5th root of y to the 5th is y. So now I've taken the 5th root of everything except for this number 2 in here. So therefore, I need to keep a 5th root and leave 2. So my final answer is 2y squared times the 5th root of 2. So this is very similar to our last problem that we did, but you're really going to want to write this one down because you might forget it. All right? So you have here, same thing, 6 root 64. Oh, OK, 6 root. We know we can write that as going to be 2 raised to the 6th power. And this could be y to the 3rd power times the 6th, right? Because 6 times 3 gives us 18. Now, here's where things are going to get a little bit tricky. All right? Now, remember, so far we've just been dealing with the square roots. And we've just been dealing with the positives, right? We're not dealing with the positive negatives. But what I want you guys to understand is, since we have an even power, right, this has to be positive, correct? Has to be positive, right? OK. So therefore, when I undo the square roots, I'm left with 2y cubed. All right? Now, this thing that's going to come into our play, guys, is we said that has to be positive, right? Because the 6th root cancels out. So we know that that value had to have been positive, right? But what I'm trying to say is y could have been, if y was a -1, would this still been a positive answer? Yeah, because what's -1 raised to the 18th power? Positive 1, right? Any negative number raised to an even power is going to be even. So -1 raised to the 18th power is still going to be positive. But now if you put -1, into y cubed, is it still even? No. Right. So we have to make sure we include just the absolute value of y cubed. So this is when you include the absolute value, if you guys want to write this down. Whenever you're taking the even root, you do your simplifying, and your answer becomes a value raised to an odd power, you have to take the square root, or you have to take the absolute value of it. All right? Even root, Answer becomes odd power. Have to put the absolute value on it. Write that down because it's going to be a test question. You'll know, and you'll have to remember that. So, ladies and gentlemen, again, when we're looking at this, a lot of times when we have expressions with variables and with numbers, a lot of times we can use that product rule of radicals that I previously told you about, and we can just separate this. This is not necessary, but sometimes when you're like getting confused on everything, or you have a lot of different variables, I like to just break everything up so I can just simplify each and every separate term separately. Do you remember we wrote this rule? If you have the product, if you have the root of an expression separated by multiplication, you can separate it, each one. So therefore, we say, well, can I rewrite the fifth root? Can I write 243 as a number raised to the fifth power? And what I spoke with Denise is, yes, if you guys try, you can rewrite 3 to the fifth power. Well, we already have x to the fifth power. That works. I'm just going to rewrite it, though, so I can do everything together. And then can I rewrite y to the, can I rewrite it? I want to use the power rule. Can I rewrite y, y to the 15th as something to the fifth power? Yes?
Wait, am I answering it?
Yeah.
Y to the third power parentheses.
Right. Very good. Very good. Does that make sense? It's to the fifth power. Y cubed is to the fifth power, right? Yes? You also could have done y to the fifth times y to the fifth times y to the fifth and done all of those separately if you wanted to. However, remember the identity element. N raised to a to the n equals a. So now, fifth root of 3 to the fifth power is 3. Fifth root of x to the fifth power is x. Fifth root of y cubed to the fifth power is y cubed.